This is lesson 611, congruent triangles. We're going to look at the triangles below and make a flow chart showing that the triangles are similar. So we'll have our three bubbles here, and it looks like this is going to be side, side, side similarity. So we normally set up a ratio of the sides. So 6 over 6 is 1, 4.5 over 4.5 is 1, and then 7.5 over 7.5 is 1. And those were all given. And that's enough to say that my triangles are congruent, and I just have to make sure that I put them in the right order. So FDE, due to side, side, side similarity. Now, are the triangles also congruent? Let's talk about what congruent means. Congruent means the same or exact, right? So that's a step ahead of similar. And yes, they're also the same, because notice all the sides are the same. They're not just proportional. They are the same. They are congruent. So, yes, this is because all the sides are equal. And that also implies that all the angles must then be equal as well. So literally, these triangles are exactly the same, which is what congruent means, exactly the same. So the symbol for similar is this little squiggle, and the symbol for congruent is that squiggle with an equal sign underneath. Why do we think this is? Probably because congruent means not only similar, but exactly the same. Which is equal, right? So it makes sense to put an equal sign underneath the squiggly sign. So that is our symbol for congruence. So it is telling us to write a congruent statement for the triangles. Well, it would be the exact same thing, triangle ABC and triangle FDE, but not only are they similar, they're exactly the same, they are congruent. So that's our new symbol there that we will be using. All right, we're going to determine if these triangles are congruent and then write a congruent statement if they are. So these triangles are similar by angle, angle. We've got our two angles there, and those are both 90-degree angles, right? So they do have angle, angle similarity. And I also see that BD is the same as BD, right? BD equals BD. So because those sides are equal, that means all the sides have a ratio of 1, right? BD over BD equals 1. So therefore, yes, they are congruent. So we can say triangle DAB is congruent to triangle DCB. All right. On to this one, we've got a pair of equal angles, a pair of equal sides. BC is equal to BC there, so that's another pair of equal sides. And so, because BC is equal to BC and BD is equal to BD, again, that's saying that the side ratio is 1, which means that these triangles are congruent. So triangle DBC is congruent to triangle ACB. All right, on to this one. Again, reminder, these mean parallel lines. So we could act like that's a transversal, and then those two angles are alternate interior angles, right? We also have a pair of vertical angles here. However, oh, and then these angles would also be the same. Or I'm sorry, I marked the wrong angles there. It would be like that. There we go. Okay. So because of where the angles are, it looks like this side belongs with this side, and those are not the same, right? One of them is 6 and one of them is 4, which is not good. So this is not enough info. Maybe they're proportionate, you know, maybe if this guy was 4, then they'd be similar, but they're not congruent so not enough information for congruence. This triangle, it's a little tricky to see what we're looking at here, but that's one triangle. And then the other triangle is here. So they're kind of lying on top of each other. We've got 2 equal angles there, 2 equal angles up here. And then it looks like they are sharing this side. So AB is equal to AB. That means that their side ratio is equal to 1. So that triangle ABD is congruent to triangle ABC. Those are congruent. All right, we're going to consider this square below. How many triangles are in this diagram? Well, I'm going to start with the big ones. I have this guy, and then if I go on top, I have that one and that one. So that's 4 right there, 4 big ones. And then I've got the small ones, 1, 2, 3, and 4. And that is all our triangles. We have a total of 8 triangles here. How many lines of symmetry does this shape have? You could do 1 down the middle. I'll do this with the highlighter, 1 down the middle, 1 this way, 1 this way to cut it in half, and 1 this way to cut it in half. So this shape has 4 lines of symmetry. And then they want us to write as many triangle congruent statements as we can that involve the triangles in the diagram. Well, I could first look at these 2 triangles, right? Those are the same. But because of all these sides being the same and all these angles being the same, that would also mean that along with those 2, these 2 are congruent. So those are 4 triangles that are all congruent to each other. So here's how I'm going to write this. I'm going to say triangle MNR. So MNR, triangle MPQ. Let's do that. So MPQ, that triangle, is congruent to triangle QNP. So that one. But those are also the same as triangle MPN and triangle QNP. So those are all the big triangles, if you will. And then we have all the small triangles that are also congruent to each other, right? We've got this guy is congruent to this guy, but is also congruent to that guy and that guy. So I can say that all the little triangles are congruent as well. So these are going to be the small triangles. So triangle MNR is congruent to triangle NPR, is congruent to triangle PQR, which is congruent to triangle QMR. So those are all congruent to each other, but we wouldn't say that the big is congruent to the small. We wouldn't say that, but these are the ones that are congruent.